SwayamPrabha. Digital India. Educated India.
Hello and welcome to this Manufacturing Process Technology Part 1 Module 33. Today we will be talking about the conventional or metal to metal machining processes, which are a major component of the industry, and the different generations of machining evolved way back from the 17th century, in fact, where power was increasingly used, either steam power or later on electrical power, for developing of the machines. And machining in all different forms, be it lathe, milling, shaping, planing, grinding, or drilling, is another way of manifesting the force or the energy through a metal to metal contact. And for doing that, you have normally the capability of producing shapes which are regular, but then later on when CNC technology took up, and it could really be from a CAD to the machining directly, from a CAD to the machining interface directly, there was a additional increase in the complexity of shapes which machining could actually do. But before that, we would like to just first investigate the machining which is more like related to conventional systems, and where mostly the outcome of the machining would be symmetrical components. So, having said that, the most important part in machining, in such kind of machining processes, are how the tool moves with respect to the workpiece. And this slide right here shows the concept of two important motions associated with the motion of the tool with respect to one workpiece. One is the feed motion, which is actually also known by the term directrix, and the cutting motion, which is basically the generatrix. So, as the name indicates, the different geometries that are expected out of machining processes are formulated by a manipulation of the generatrix and the directrix. For example, let us say in case of a shaper machine or a plane machine, there is a movement of the tool with respect to the workpiece which is mostly on an XY plane. So, this right here shows the rectilinear motion of the feed direction and the cutting motion, and they are perpendicular to each other, making a 90-degree angle. And so, therefore, you can have a XY plane generated because of such directrix and generatrix, both straight lines perpendicular to each other. Okay. So, we can obtain a plane surface out of a straight line generatrix and a straight line directrix, and the process can also be known as tracing. Similarly, in the case of a turning center, you have normally the motion of workpiece in a circular manner, and we can say that the generatrix direction or the cutting motion that happens is in a circular manner, and the relative feed direction of the tool with respect to the workpiece is again straight line. So, a straight line in a circle in generally will yield or which make an array which is like cylindrical in shape. Okay. So, of course, the straight line is in a direction perpendicular to the direction of the cutting velocity. So, that is very important, particularly here. Or in case there is a motion which is related to circular motion of the tool and the feed motion of the tool in the direction almost in the same plane as the cutting velocity, okay, or towards the direction of the cutting velocity. In that case also you can generate a plane surface. Okay. The example of that is milling. So, in a milling system you have, let us say, a circular motion, and the cutting motion is really along a circle, and the cutting velocity and the way that the chips get formulated is, particularly in a face milling operation, is how the tool engages in a circular manner at different points. It is a multiple cutting tool, point cutting tool, so that you can have chip formations along that circle, and then you basically moving it in a direction either perpendicular to the direction of the cutting velocity, okay, and so you get a plane surface based on these two motions. So various complex geometries with different symmetries can be obtained with different cutting motion directions and feed directions, and that is how you understand the basic engagement of the tool process with respect to the workpiece. So let us talk about now some of the processes. So we have the example of turning, where the workpiece rotates and the tool moves to the left direction. You can see here that the tool is moving in that perpendicular to the direction of the cutting velocity, which is actually tangential to the circular motion here, and this generates cylindrical surface as we had earlier illustrated. So this is a case of straight turning. There is a cutting off. So basically this portion is now being shaved off using a parting tool. So this surface is completely eliminated from the cylindrical surface. So a cutting tool moves radially inwards, okay. You have again milling, which is another form of cutting. In slab milling operations, you have a rotating cutting tool, and it removes the material from the workpiece as shown here. The milling tool is typically mounted onto an arbor, which is a axis which provides rotation to the cutter, and the workpiece is moved actually perpendicular to the workpiece is moved in both x and y direction with respect to this particular cutting motion, and such examples are known as slab milling. You can also have different other forms of milling, like the face milling example that I was providing, where the cutting motion is also along a circular plane, which is probably in the similar direction. So the cutting velocity, for example, in this particular direction is similar to that of the feed motion, okay, or is similar again to the direction of the feed motion of the tool in the y direction. So in these particular examples you can have a planar surface, okay. Then you have end milling operations, where you can actually have a rotating cutter, and it produces a cavity, as you can see here, right about here. So these are different variants of the milling process. Some other common machining processes, particularly for turning, you can have a lot of different operations. For straight turning shown here, there is a taper turning, where the tool goes from in a tapered manner with respect to the rotating axis of the workpiece, and it generates a profile identical to its motion. You have profiling, where you have a certain shape, XY shape, which is typically the curve of or the path that the tool follows with respect to a turning workpiece, so that you can have a complex shape profiled onto the workpiece. You have turning and external grooving, as can be indicated here. You facing operation, where one portion of the circular workpiece is completely removed or shaved off. You have a face grooving operation, where by a different orientation of the tool, with tool moving in a direction perpendicular to the circle of motion, you can actually have a small groove, as you can see in this particular example. This shows that of a cutting with a form tool. So you have exactly something imprinted, the negative of something imprinted, of which the tool is shaped up to, and so you can actually have a shape imprinted directly by cutting it with the form tool. You have boring and internal grooving, as illustrated here, which is typically done by a boring tool mounted on one of the spindle axis of the which is sort of coaxial to the workpiece direction. You can do in a similar manner by using a drilling tool, to drill on side of the cylindrical workpiece. You can do cutting off by having a tool which would be enabled to go in a direction perpendicular to the radial direction with respect to the workpiece and produce a deep cut. You have threading tool, where the thread moves, the threading tool moves at a certain feed, and it generates threads of a defined pitch, because of the motion of the tool in a direction parallel to the axis over which the workpiece is rotating. You have a knurling tool where you have a pattern impregnated onto the surface, which is exactly the negative of the pattern that the tool contains. Okay. So, these are different operations that you can actually use the turning system or lathe to obtain. So, if we talk about the basic processes of machining, it is really about peeling off of the material. So, as I told you earlier that there is a metal tip which would be engaged with another metal, which is the workpiece. In our case, the metal tip is harder in comparison to the workpiece, and it actually plows into the metal and starts to peel off the metal. That is how you do conventional machining, or that is how the chip formation takes place within the system. So, if I look at this figure right here, it talks about a basic shaping or a planing process, where the surface obtained in both these processes are planar in nature. This is the cut surface, the surface generated, you can see here in this portion of the figure, and you can see how the peeling of action is happening at the point of engagement of the cutting edge of the tool, which is actually this edge right here with respect to the workpiece. So, you are having a portion of the workpiece which was otherwise making this particular substrate or surface or constituting this particular surface cut off, so that you have a similar surface produced at the bottom here, and there is a certain feed at which you can move this tool inside, whereas moving it at a certain feed velocity perpendicular, and so that is how you generate a XY surface of the work, corresponding to the different feed and stroke. So, you have a tool and you have a surface which is produced. So, in shaping process, the cutting tool is provided with reciprocating motion, and every cutting stroke the work is fed perpendicularly to the cutting direction. Since the cutting is not continuous, it is known as an intermittent cutting process. It is not similar to that on a lathe machine where you have a continuous flow of chips coming out. When the job is long, and it is very difficult to provide a long cutting stroke with mechanisms used in a shaping machine, generally in that kind of a case, instead of moving the tool all over to the whole span of the job, you basically move the workpiece. So, the workpiece provides the cutting motion and the tool merely gives the feed, and that operation then would be known as planing operation. So, only difference is in terms of the workpiece size and what moves. So, the primary cutting motion would be generated by the cutting stroke of the tool if it is a smaller component, and the operation then therein would be known as shaping, and vice versa if the workpiece is the one which is generating the cutting motion, whereas the tool is only giving the feed, and it is a let us say a longer or a larger component, then that kind of motion is now known as the planing motion. So, but effectively what you can see is the peeling process which is going on here. You have similar examples where the same, this is shaping and planing happening. In both the cases you have peeling off of the workpiece which is happening, and you can actually do a mechanistic diagram here which I am going to illustrate later, where we can see how the chip etc. is generated, as a function of the rake angle or different other forces like the cutting force or the friction force which comes in there. Okay. So, similar kind of a process of peeling can be illustrated even for the turning operations. So, here also you can see a tool, and you can see the level of engagement of this tool with respect to this tool surface or tool edge, which then peels off the material, the surface material, and it basically tries to again remove the material by peeling action. It is a continuous process again, because when the surface is rotating with respect to this edge, there is a continuous removal of the chip material from the workpiece surface. So, the surface obtained in turning process is generally cylindrical. In face turning, a flat surface can be obtained. The machine tool for this operation is a lathe, and the tool is provided with a feed motion as the workpiece is rotated, and the tool path is a sort of helical path that it follows for removing of this material. Here you can see this is the surface which is generated because of the cutting motion, and this was the surface which was before, which is being cut to generate this surface, this new surface. So, here the machining operation is a continuous machining operation. You can see how again the chipping action happens here as a function of the different forces and the angles and we are going to do all the analysis of how this chipping action happens in a later on stage, but that is how the basic of turning process happens. You have a similar kind of a strategy for milling processes. Here for example, you are seeing 3 different kind of millings. One is a slot milling, another is a face milling, another is a T slot milling, and I can see here that there are different other kind of millings. For example, in slab milling case, you can see that the milling tool is mounted on an arbor and there is a feed motion of the workpiece. Similarly, there is again another kind of a slot milling case here with the similar kind of a vertical mounting of the milling cutter, or a form milling where a certain form or a shape is impregnated onto the surface because of the form of the tool which is there. So, the same operation of a rotating tool which is a multi-point cutter is being utilized in various forms to obtain different kind of peeling operations as the milling system. So, in milling, the tool possesses a number of cutting edges. It is provided with a rotary motion. The work is gradually fed, due to which small chips are removed by each cutting edge, and finally it produces a flat surface. Okay. So, but then again, if I look at the way that this milling operation is performed, it is really about the way of that peeling process again, which is happening somewhere here. So, if the engagement of the cutter happens at a portion somewhere here, there is the original surface which was actually this surface which has been cut off now into this new secondary surface, and there is a milling cut the chip which is coming out because of the engagement with the cutter. So, effectively again it is the same peeling process. So, in all these figures and strategies, it is kind of clear that irrespective of whatever be the name or the shape that is obtained in the machining process, it is about relative motion of the tool with respect to the workpiece in one way or the other, and it is about also the engagement of a cutting edge which thereby peels off the material so that you can have cut metal. So, having said that, and the basic premise being clear, now we can do some mechanistic calculations in a manner so that we can understand this process of peeling or material removal in greater depth. With this, I would like to close this particular lecture, but in the next module we are going to start off from here, do the various kind of millings which are possible, and then we will slowly get into how this peeling process can be obtained mechanistically and what are the different issues associated with the different force balances which would happen there. So, with that I would like to end this module. Thank you.